workshop on explainable artificial intelligence in manufacturing. It is organized by the cluster of European projects on AI in manufacturing. There are different projects, as you see the logos below, which focus on different aspects of AI in a production line. Today, we have 4 of these projects presenting different aspects of explainable artificial intelligence in manufacturing: the Project Assistant, Project Knowledge, Project Explainable Ai, and Project Star.
Bij mij, X-Men.
So without
ben is die ochtendreskast. Okay.
So without any further ado, I would like to just give the floor to Paolo for some practical matters and rules on how we talk today. It's meant to be 2 hours. You will have the opportunity to ask questions at the end of each presentation, but also at the end of the seminar, we have foreseen some buffer time for this. So Paolo, maybe you say a few things about the rules, and then we start with the first presentation on explainable AI in manufacturing with Eduardo. Paolo, the floor is yours.
Okay, thanks, John. Just a couple of words on the rules. We are quite a lot today. For now, we are almost 35, and I expect some other people will join. First, as you have seen, the meeting is recorded. I will kindly ask you to stay on mute unless you want to interact with the speaker that I suggest you can make on the chat. Each speaker will tell you if he wants a question at the end or not. You will get a presentation available after the meeting. And also the agenda, and that's it for now. So John, the stage is to you again.
Very good. Let's start with the first presentation of Eduardo on responsible artificial intelligence in manufacturing. I guess this involves explainability as well. And yes, please make sure that you mute yourselves unless we ask you to ask a question. Otherwise, Paolo will do this as host. Thank you very much. Eduardo, please.
Okay, 1 second. I want to start sharing my screen.
Yes, we can see your presentation, Eduardo. Yes.
Okay, let me check actually if it's sliding. Yeah, perfect. Okay, good morning, everyone. Yes, my name is Eduardo Meister. I'm representing Insight Center of Data Analytics over here in Ireland, and I'm going to do a presentation of a framework development for responsible AI in manufacturing. Before I go into the details, just a little bit of what I'm going to be presenting today. First is an introduction of where this is involved related to assistant before we move forward in the direction of specifically what is this framework about, okay? So first I'm going to talk about assistant, some ethical components, some risk consideration, and then I will go for the framework. So for those that don't know it, assistant is a funded project from the European Union. It's about 6 million, and this has 12 partners. 6 of them are from universities and research institutions, and another 6 are from manufacturing sectors company that includes energy sector and also the automotive production manufacturing sectors, okay? And the idea, the main objective that you could look into the page and was part of the proposal, the main objective is aim to develop a breakthrough solution for the manufacturing industry, of course, using artificial intelligence. So what is assistant about is the idea that work in the revolution of Industry 4.0, that most of one of the considerations that we have in the manufacturing sectors right now is mobility or dynamicity in order kind of be a response to the change that will exist into the market. So the idea is kind of use different digital twins or real, very good representation of what is the manufacturing stages in order to come with using generative designs and come with suitable recommendations for the users. The idea is interact with the real manufacturing process using these digital twins in different stages that have different time domains. For example, we have process planning, process production, scheduling, and when we go to the smaller kind of like when we go in the smaller time frame, we are into real-time control. So there's going to be different digital twins that are going to be used in each one of these stages of the process. Okay. There, over there in the screen, you can also see, let me move this. I don't know if this is better. You can see different objectives, and one of them that is really important and is the main participation that I'm doing in this project is the responsible AI development in terms of two scopes. That scopes, one is that we have to define or construct an architecture within the project for the deployment and development of each one of the components that is ethical by themselves. So that means ethical by design, and at the same time develop a methodology or a framework that is going to be useful for the whole manufacturing sector in order kind of like going to be a combination of different guidelines and standards and frameworks in order for the manufacturer use kind of a pipeline that is going to be an extension of maybe some vaccinated
and was transferred to a hospital in Plano for treatment. His wife, who was vaccinated, was sent home to recover. West says in the post he is now even more dedicated to fighting against vaccine mandates. He says he's taking hydroxychloroquine and ivermectin, two drugs health officials say should not be used to treat COVID. The latter is a large animal dewormer.
And overnight, a strict lockdown in Australia's biggest city was partially lifted after 100 days.
I'm hearing someone cannot focus. Thank you.
Got it. Thank you.
So yes, let me go back to where I was. Yeah, one of the objectives is develop a framework that is going to be a guide for the manufacturing sectors in order for develop ethical components in the manufacturing sector. In this slide, it also show the whole work package of assistant, but only one of them that is interacting with each one of the technical ones. Work package 3, work package 4, and work package 5, that are the technical components. The work package 2, that is the ethical component, that is going to interact with each one of them in order for securing this development of AI components under each one of the regulations and this pipeline that is constructed. So in this slide is kind of a little bit of introduction again for the trust components of where everything that's come. When we try to define or think about like what components are necessary in order to develop a trust AI component, we have to make sure that they are lawful, ethical, and robust. Ethical considerations come from 5 different imperatives that were defined for the A4 people in 2018, and that was later on translated in these 7 requirements. So these imperatives are the non-maleficence, beneficence, autonomy, justice, and explicability. A lot of have been driven into non-maleficence more than beneficence right now, and there's a lot of things going, for example, in human-centric considerations in terms of autonomy. Justice is more related to, again, non-maleficence and explainability. We know that there's a lot of technical development right now going on. So I'm going to look a little bit move forward in a consideration that has been doing a lot recently, that is the consideration that it's not only a requirement that we have to focus right now, into the development of AI components is that we have to avoid all the risks or the harmful considerations that could come during the development and use of the AI components. So there's several references to this word risk in the white paper Artificial Intelligence, the Artificial Intelligence Act. You can find this in several ways. So we know that the consideration of how to handle AI components have to come for the consideration that we are not going to avoid ethical issues by securing that we are not going to go over risk condition of the AI component. Now, the main risk related to the use of AI concern are in that square over there. That one is protect the fundamental rights. The second is safety, and the third is liability related to issues. Okay. Now, what is risk? Basically, a risk is a combination of a probability and the consequences of the event. And they can be, by definition, is commonly considered positive or negative. But normally, in the concerns of non-maleficence, okay, has been driven this risk consideration into hazards more than in the both gaps of seeing the effect of the AI component. So normally, or what it's seen right now, this is focused only on the non-maleficence component, and so the risk considerations are said to be only on hazards. One of the important things is like that for a risk to materialize, it's required to an event must happen. And in order to kind of develop this framework, we have to think of what are the effects or what are the AI functionalities that can make these risks to materialize. Okay, over here in these slides, you are seeing a little bit of a connection that is being driven in order between the ethics, trusts, and risk considerations that, again, going into this consideration that we can connect trust with risk, and the risk through the management of it, we will secure again the trust. That gives us a direction of how we should look in the way that we will manage each one of the considerations, independently if we're going to be looking to just the requirements right now, or we're going to move a little bit forward in order of considerations that we want to incorporate values within the AI components. In the middle column, you can see again that we have connected the ethical consideration with the trustworthy requirements. But of course, there's another considerations that we need in order to secure trust, that there's the lawful and the robustness. And each of these components can be connected to risk considerations. These are, of course, you can connect, you can do more connections, but this is that are the most relevant that we have foreseen that, and it's going to come out here soon in a manuscript that is going to be an explanation of this connection that are going on. And this risk management is the component that we're developing in order for handle AI development and deployment. Now, I think that most of the persons have seen already something like this, that there's already in the a definition of risks levels in function of the domain that the AI are deployed and their functionalities. So there's already a trend of some regulations that it says, okay, you are only allowed certain types of functionalities, and that will develop or settle or classify an AI component at different levels of risk. So we know that at least the classification right now moved into an acceptable risk, high risk, limited risk, and minimal risk. And that settles some definition of requirements in terms of the trustworthy requirements. But that doesn't mean that's the minimal. That doesn't mean that you cannot look for other components. Moving a little bit forward. So the idea of what we are looking right now for developing as a framework is a combination of a risk management component, because at the end is a consideration that is a connection between the trustful components with risk management. So the idea that we are developing in assistance is developing one, a general that is external, that's going to be useful for the whole manufacturing sector, and another that is specific or internal, that is just for assistant, okay? And these frameworks that are developed are a combination of the RASPs, the Trustworthy Guidelines, ISO 31000, white paper, and etc. There's a lot of documents that were guided. Internally, we are looking for just the RASP structure that is come from the risk architecture, structure, and protocol. So we have developing a document that's going to be the guide of how internally we are going to develop this AI component assistant, but it's not necessarily useful for the whole manufacturing sector. I'm going to move forward then when it's going to be more general. Over here, again, you can see different considerations from the RASP. So the main document that we are building in terms of for the internal management of framework are the risk management policy. So that's going to be one of the deliverables that we have in the project that is going to be maybe useful for another manufacturing or AI projects to have a guidelines in order how to manage internally their risk considerations. But it's not, again, for the whole manufacturing sector. Now for this risk management considerations, we are going to have the risk management policy that is going to, for example, define purposes, scope, and of course, it's going to be defining the specific for this, specifically for assistant, how to manage the AI and the development of the AI component in the different technical components. Now, when we're going to move into the external management that's going to be useful more for the manufacturing sector, we are looking forward to something related to the ISO 31000 risk management that is divided or can be as three main components. One is the principles, another is the framework, and the third is the process. In terms of the principles, is a definition of, as a general definition of how a framework for risk management should look like. The framework itself is how it structurizes the interactions that is going to be within the use of this framework. And finally, the process is exactly a methodology a continual methodology to use for handle the risks. And we are developing each one of these components, but the first two that are more general, I want to just mention that it has one important consideration that has include human and cultural factors. So it allows the incorporation of not only the requirements, also it allows the incorporation of values that are going to come from the manufacturing sector, of social considerations that need to be included within the risk management protocols. In terms of the principles, again, it's just a little bit higher description of what I showed before. It requires to be integrating. It has to consider design, implementation, evaluation, and improvement. One important consideration of here is the evaluation, that it mentions that it needs KPIs. That means that we need a way to track what is happening with risks. So we are also working in the definition of ethical KPIs that are going to be useful for the manufacturing sector in order to track these risk components that are going to come from each one of the trustworthy requirement definition. So we are going to have KPIs for the manufacturing sector specifically that will be helpful for tracking this. Finally, we have the risk management process that is basically a pipeline that is a continual process that consider identification, analysis, actions, monitoring, and control. Over here in the slides, by just the colors, you can see the correspondences of each one of these components. And it's a pipeline that we have modified specifically for the consideration of the actual regulations that are going on related to AI, and at the same time being useful for connecting to tools that already exist in the manufacturing sector in order to use this approach. So we don't want to do a connection out of nothing. We want to just make it complementary what the manufacturing is using for risk management right now. So this is a general structure that says how, for a bit more general. I'm not going to define anything yet because this is going to come out in publication soon. That is a how we are going to do the combination of each one of these components for the ISO 31000. So that we have, for example, for the construction of the principle, the risk management in the manufacturing principles, we have considered ethical imperatives and the values that come from the stakeholders. That's going to be useful for the principles definition. For the framework, it's going to be the consideration of the new regulations, actual regulations, and the definition of some KPIs. And again, for the process, the risk management process, we have something that considers the specific context, definition of risk identifications that we have at least right now, these 4 levels that have been defined in the AI Artificial Intelligence Act, and risk treatment methods that specifically for AI components. And this is going to be producing, and therefore, the risk management framework for responsible AI that we are proposing in Assistant. This is just as showing that this process is a pipeline. We have already defined it, but it's going to be soon in some publications. So hopefully it's going to be maybe at the end of the year or the beginning of the next one. That is going to be seeing these pipelines in order to do the risk management process. Okay, and again, just KPIs that are going to be the metrics are going to be within also this risk management process that are going to be useful for the incorporations in the manufacturing sector. I don't know how my time right now is 10:22, so I'm going to just leave some time for questions if anyone has something to ask. Thank you very much.
Thank you, Eduardo, and I invite anyone who has a question to type in the chat. My question for this presentation is that, is this, because you say it's a risk management framework, right? I did not quite get the mitigation measures, right? So I thought that what you presented is mostly focused on the detection of the risk, right? And on the grading, right? So what are the, I mean, if you once you detect that you are at risk, right? What do you do to mitigate? What are the measures you do to mitigate in the framework? Is the question clear? Yeah.
So if your question is how you are going to be detecting?
Not detecting, mitigating.
Okay, that you
mitigating. Suppose you have a risk, right? You run the ISO,
exactly.
3100, and you see, you've got a risk from this AI system, okay? And
yeah.
then what do you do, right? Because if you said that you want to increase the AI effectiveness, right? In the last slide, the overall operation of AI. So you need to do something, right? So that the AI continues to operate.
Yeah. First, one of that consideration is that you have already settled some levels of these 4 levels that they say the level of risk of the AI components. And if it's a high risk, we know what trustworthiness components you have to look at, okay? And so that's going to be the first key of what components you have to be looking at your AI component. Now, in terms of the, for example, again, just one that is going to be super easy to understand in explainability, that we have a lot of tools use it now. So for example, if the AI is one of the considerations is going to be explainability, is recommendation depending on, for example, what data structure is used, what could be some generative explainable methods that you could integrate into your AI component. So the idea is a recommendation based, not an obligation, it's a recommendation based on what is your AI component doing.
Okay, so just to make sure that I understood that, right? So you detect and then you provide a recommendations,
yes,
a recommendation about what is good to do. So,
yes,
for example, to mitigate this risk, you have to explain how this component works, and if you do this, then the risk is lower or is mitigated.
Exactly,
or
exactly,
is removed.
exactly. One of the considerations, though, that when you do this this pipeline, okay, the idea is that maybe some new regulations will come in the future because it's very dynamic right now. Okay, so the framework include the possibility of new tools or new regulatory to be incorporated within the general framework. We don't want something that is going to be static, given the dynamicity of what's going on right now with the AI.
Yes, okay, so in this respect, the mitigation measures cannot be static because the regulation is not final, right?
Exactly, because it's going to be some modification.
The AI regulation is still a proposal, right?
Exactly. But the idea is that you can use the same framework, but you are going to be doing in the first part that is kind of like when you are evaluating or checking the scope of your system, is going to be adaptable of what is going to be maybe the new regulation that could come.
Okay, yeah, clear to me. Yes. I don't know if there are any other questions in the chat. Otherwise, we can move on to Christian Beach and Knowledge Project. Christian, the floor is yours. I don't see any other questions. Christian, the floor is yours.
I have a question.
Okay, yes, please.
So thank you, Eduardo.
Introduce yourself and ask the question. Eh?
Yeah. Thanks, Eduardo, for the nice presentation. I have a question regarding once you identify what are your risks in the pipeline, what are the key steps you are taking to make sure how fair those risks are? I mean, are those risks, you know,
I would like to tell you right
genuinely
now that because that's related to the methodology in order for risk management, but that's going to be published. So I will not share that right now.
Okay.
Okay, good. So what we can do, I think, is once we have the publication, we will share about this in the cluster page.
Yes.
And we will ask, you know, we will share the information with the participants of this workshop.
Mm-hmm.
Now we've got Eduardo, one more question. Sorry, Christian, you'll have to wait a couple of minutes. By Mark Anderson, is this emphasis on risk meant to support the EU draft regulation, which classify AI according to risk? Do you think it moves too much towards the legal rather than the ethical side of things? Well, I think this is for you, Eduardo, but I guess that you started by presenting, right, the pyramid of the AI regulation, but yes.
Yes, but the thing is, again, that pyramid is what is classified right now, but maybe in the future it's going to be more levels in that pyramid. So there's going to be further classifications. So it's going to be some modifications of it. And you will have to look not only to that. And this important thing is we want to consider that something that hasn't been done a lot recently is the consideration of values. Company values, even though we're just looking for regulatory components, they are not considering that maybe some values that you want to incorporate into the AI components. So it's not only for requirements or regulatory, also for intrinsic values of the manufacturing sector or company.
So with respect to Mark's question, right, because Mark Anderson is asking if you are focusing too much on the legal part and less on the ethics. So you are saying that the framework is general, and if you have ethical things like the corporate values, for example, you can incorporate it as a feature, right? As a,
yes.
As an artifact in the framework.
Yes.
I don't know, Mark, if this answers your question, or if you want to follow up and say anything more. Okay, thank you, Eduardo. And now I think it's time for Christian and Knowledge Project. I think, Eduardo, we would appreciate if you could be around. Maybe in the end we have a discussion and more questions.
Okay, so thank you very much. Let me first share my screen. Sorry, I first have to start the presentation. I hope you can hear me. And now I hope you can also see my slides. It should work right now.
Yes.
So yes, then we can start. So welcome to my presentation. I'm glad to see so many people and also colleagues here in this online workshop. My name is Christian Beeks, and I am from the University of Münster. And today I would like to talk about AI-powered manufacturing services, processes, and products in the Knowledge Project. This talk is meant as an overview about applying AI, or more particularly XAI, to the domain of Industry 5.0, and has a particular focus on trustworthiness AI. So before we start, let me give you a quick overview about the agenda of my talk. First, I would like to introduce the Knowledge Project and then generalize this idea to Industry 5.0. Then I would like to go over to trustworthiness AI and linking this idea to XAI, because we all know that XAI is one prominent mean to achieve trustworthiness. And then I go quickly over some important points that we consider in the Knowledge Project in order to achieve trustworthiness of the entire systems lifecycle, before we then have some time for discussion. Well, I think we all agree that, let me put this window a little bit here in my video, sorry. This should work now. Yeah, this is better. I think that is a good, or that we all know that artificial intelligence is one of the biggest megatrends towards the fourth and even the fifth industrial revolution, right? We have, or we make use of AI in form of systems, of sensors, of robots and methods in order to make the manufacturing process more intelligent, more smart, and more agile. And this is basically possible because we produce a lot of digital data. In the manufacturing domain, data is coming from processes, machines, control systems, sensors, and other IoT devices. So what we see is that there's a lot of digital value that needs to be used in order to improve production processes. And if we put both together, data and AI, there are new possibilities in order to derive at more agile, reusable, distributed processing, also some systems that scale to the cloud or edge to cloud continuum that are standardized and collaborative. So actually, I think we all agree that there is a necessity, if we compare to today's techniques, we all agree that there is this necessity that we need to provide and develop new trustworthy AI, or basically then XAI methods. And this is something that is going to be happened in the Knowledge Project. I think pretty sure that's happening in every project, but the Knowledge Project is one of the projects from the ICT 38 call, which is funded by Horizon 2020. It has around 12 participants from 7 EU projects, and the EU, or the Knowledge Project, will or aims at developing a new generation of AI methods, system, and data infrastructure in order to improve manufacturing services, processes, and products. You see here this map, and I don't want to go further into this project. If you're interested, you can have a look at our website, and we also participate in this cluster, and I think also in further upcoming events, we have the chance to talk to me or to my colleagues if you want to know more about the Knowledge Project. So what we want to improve is actually the traditional manufacturing that adapts to market and customer needs. We want to make it more intelligent, making products and processes more intelligent, let them be more efficient, more productive, more accurate planning, at least costs. And of course, we want to put the user in the middle of this process. So as we all know, human centricity is becoming very important. And this brings me actually to the next paradigm towards Industry 5.0. We are all familiar with Industry 4.0, where we know that we make use of cyber physical system in order to improve our manufacturing process. And now there comes a new paradigm, Industry 5.0, which is an open and evolving concept that includes three major aspects. The first aspect is sustainability. Well, that is clear. If you look at the greenhouse deal and so on, we know that we should reuse and recycle natural resources, that we should reduce energy consumption and greenhouse emissions. The second important aspect in Industry 5.0 is to put the human needs and interests at the heart of the production process. So basically can be understood as the humans should not compete with the robots or with the intelligent systems, but they should work together in order to improve manufacturing. And the third thing is resilience, because we have to be robust in industrial production. It could always happen something like COVID-19 or the flood or something else, that we have to develop a higher degree of robustness in digital production. And all these, I cannot see everything. To achieve this, we need a lot of data, of course, a lot of method. And to summarize this, we need a lot of digital technology that we trust. Then only if we trust something, we will apply it, we will put it down to the shop floor and make actually use of it. And this brings me, after this introduction, to Trustworthy AI. And I'm pretty sure that we already know now what Trustworthy AI is. Yeah? Trustworthiness means that an AI system is lawful, respecting all applicable laws and regulations, that an AI system is ethical, meaning that the ethical principles and values are respected, and that an AI system is robust both from a technical perspective and also from a social perspective. So let's go into this and have a look at trustworthiness. As you can see on the right-hand side, trustworthiness is a product of many aspects. What is important here is stability, robustness, explainability, interpretability, interactivity, confidence, and reproducibility. And actually, you can define trustworthiness as the confidence of whether a model will act as intended when facing a given problem or not. And you may now ask, well, why is that important? Why do we need trustworthiness? And actually, that is quite simple. We want to do predictive maintenance in order to improve the efficiency of the maintenance process and reduce the overall maintenance cost and time. Or if we want to do quality management in order to reduce the cost of inspection, or some kind of supply chain optimization in order to produce in a more cost-effective manner. Whatever we want to do, we have to be sure that the model behaves as expected, right? That you understand what is happening, that the output is put or is understood in relation to the data that you use. Otherwise, if you do not trust the model, if the model does not behave as expected, you will not use it and you will not run it automatically. And so the question is, how can we achieve trust, right? And one way to achieve this, one very technical way, is that you look at the model and you try to come up with detailed explanation of its decisions. And this is the typical thing that we want to do with XAI, that we try to explain why the model is behaving in a particular way. And this is, basically what brings me to the next slide. XAI is basically understood as achieving trustworthiness between AI technology and consumers. And this is the main purpose of XAI. And XAI itself then develops mechanisms and techniques to provide insight into AI model. These insights will basically allow users to get justifications and explanations of the results. right? You know what is happening. If something is made or a decision is made automatically, the user can look into that and say, okay, I understand that the explanation is given in a human interpretable manner, and it makes sense that the method, the algorithm, or the system behaves as it does. And then you can see on the right-hand side a nice figure that I've put from a paper here. You can start basically, or the question is, how do you achieve trustworthiness? You can start with your XAI method, and then you aim to achieve stability, robustness, and confidence. Stability means that you try to make the model resistant against disturbances that are not created by humans. These are some factors, some external factors. Perhaps you have a shop floor and then the temperature increases or the humidity increases. And then you have to make sure that your method behaves as expected, and XAI could help you to dig into stability. The second thing is robustness, because there can also be some perturbations that are created by humans. It could be that we try to optimize the process manually, that we try to change the parameters. If we look, for instance, at an injection molding machine, we could try to improve this process manually by increasing the temperature, reducing the plastification time, and then try to come up with more products in the same amount of time. But maybe this is not a good idea. And if you have an XAI method which is robust, or which addresses the robustness of the model, then you can have a look at this. And the third thing is, of course, the confidence, what we have seen in the talk before, that you need a measure of risk, that you need to somehow quantify whether the suggestions of the model are correct or not. And if you achieve all those three things, then you're on a good way to have a trustworthy method. You can most probably increase trustworthiness and bring your AI method to the shop floor. So XAI basically aims at boosting the transparency of AI models, which are otherwise unintelligible to the human, right? If you use a very sophisticated model, a very deep neural network, you have no idea how this model behaves. And now XAI comes there with some methods that try to help you. And what you basically have to distinguish is between intrinsical interpretable models, such as linear regression, decision trees, or k-nearest neighbor classifiers, and post hoc explainability models. These are the high-performing but complicated models, such as deep neural network, very complex architectures there, or support vector machines that you then try to explain with more interpretable, with more easy models. And if you do this, you basically try to explain them, and what you will basically offer are some kind of explanations, right? You can distinguish between model-based, attribution-based, and example-based explanations. Either you want to come up with an idea how the model is working in general, or which features, which attribute are important, or you want to provide some examples that are some prototypes or criticism that way your approach really works well or not so good, right? These are the kind of explanations. And then you can explain your model locally or globally, which means that you only explain a certain part of the input or a certain part of your data or the whole data that is available. And you can have specific versus agnostic explanations. If you, for instance, use Gaussian processes, you have some kind of specific explanations because the covariance function of these processes itself are explainable. Whereas if you have some more complex model, you will most probably use some agnostic explanations. Whatever you do with the explanations, you have to make sure that it fits to the audience, whoever wants to interpret the model. Is it a data scientist? Is it a machine learning engineer? Or is it some other stakeholder from the management level? You have to make sure that the explanations that is provided by XAI are fit to the needs of the users. And yeah, basically many techniques have been developed in this field, and they gain more, or they aim to gain more insight into the AI models, and thus try to increase trust at the AI systems. So now I want to go one step further. I want to show you how we aim to increase trustworthiness in the knowledge project, what means we actually aim at in order to do so. And what is important here is to see that trustworthiness does not only start with the system or the model, but data is also an important aspect that has to be taken into account. So it is important to start with that. And we all know that there is one very nice principle that you could use, the fair data principle, which is nowadays, I think, it's mandatory for every EU project to comply with these principles. And as data is generated across various different layers in the project, you should make sure that the data is fair. And fair means that, first of all, your data is findable, meaning that you use rich metadata, that you use unique identifiers and index the data so that you can find it again. And that, or in addition to that, your data should also be accessible, meaning that you use some kind of standardized communications protocol so that humans and machines can access this data. And for this, you should store or manage your data in an interoperable way. Use common formats, standards, and a common vocabulary that helps you to bridge the gap between different systems. And of course, you want to reuse your data, right? Perhaps in other projects, if possible. So you have to provide a clear documentation, a clear structure, and make sure that you use the right licenses that others can also use your data. Within the knowledge project, we want to achieve these fair data. We use some means to make the project data fair. First of all, we use naming conventions and versioning. I mean, this is somewhat important if you have, I don't know, CSV files, JSON files, Excel files, text files, whatever kind of data comes. Make sure that you have a clear naming convention and that you also have some kind of versioning in order to go back to older versions. What we also apply or plan to apply are some standards for metadata. We try to describe the data generated in the pilots or used for training the AI models by VCC Think Description or OCC Sensor Things API or sensor measurement lists. Another important thing is to make the data publicly available, and not only the data, but also the code. And here OpenAir or Zenodo or GitHub will be used in order to share our data where appropriate and the corresponding code. And then as we're working, or all of us are working with AI models, it's a very good idea to use some standardized AI model description, such as PMML, ONNX, or PFA, in order to have a unique way how the models are basically described. And within the project, data will come from the pilots, from the machines, and to transfer the data to the cloud, we also have to use some well-known messaging technologies. We will, I think, most probably use MQTT and some more secure protocols, AMQP, in order to exchange messages or for brokering. And some more standard interconnections, Wi-Fi-ware, HX Foundry are used. And of course, concepts and ontologies such as the E-class, OVL, or good relations are then used in order to make the models that we train in the project available through the knowledge marketplace. So this is on the data side, but then we can also have a look at the system side. And we've already seen that if you want to realize trustworthiness as depicted in the figure, the first step is for a trustworthy AI system is to define the main rights and principles. And these principles are respect for human autonomy, prevent of harm, fairness, and explicability. And then we go or continue to implement these with the 7 requirements for trustworthy AI. And there we adopt different technical and non-technical means. And basically, this is where XAI comes into play and helps us to make the available models more explainable. So let us quickly focus on the 7 requirements. I think you all know them. I don't want to recap them again, but here you see the main requirements that you have to meet. And let me give you some example how we approach this in the knowledge project. And for this, I would like to first focus on one requirement on top, the human agency and oversight. Human agency and oversight means that AI systems should empower human beings, allowing them to make informed decision and fostering the fundamental rights, right? And at the same time, proper oversight mechanisms need to be ensured. This can be achieved, for instance, by putting the human in the loop. And in the knowledge project, we will develop the so-called knowledge platform. And this will promote a decision support system with Explainable AI, in order to support the decision making and also to enable people with no machine learning background to apply AI solutions and have control over this. So what we will basically develop will be some interface or some dashboards that can be used, that are human-centric, where human can put different semantics and include some expert domain knowledge in order to steer this process. The other thing that I want to talk about a little bit, it is the requirement of transparency, which means that the data, the system, and the business models related to the AI models, they should be transparent, right? And we could do this in different ways. One is traceability. We can try to track data sets, algorithms, models that are used in the knowledge systems in order to have some metadata with that and to reuse this and issue them or expose them in the marketplace. The other thing is explainability. This is what I'm talking about, which will be given a special focus in the knowledge system, where we aim to deliver intelligent interfaces for suggestions, recommendations, and notifications that can be used in order to explain the decisions or recommendations made to the user. And for this reason, we will use XAI. All right, so that is basically everything I wanted to say. And let me go through the discussion and give you some concluding remarks. I think we all aim for a sustainable, human-centric, and resilient European industry. We all agree that manufacturing services, processes, and products need to be improved by intelligent synthesis of technologies, tools, and methods. I think, or we think, that trustworthiness is key to successful utilization of XAI. And within the knowledge project, we aim to address the need for new XAI solutions, which are agile, reusable, distributed, scalable, accountable, secure, standardized, and collaborative. So with this, I would like to close my talk. Thank you very much. And now I'm happy to take some questions. And I see the first question is already.
Okay. John, I see there is a hand up.
Yeah, please. I want to ask something, but let's take the hand. I think.
Is it my hand, Asher?
Yes, please free to introduce yourself and.
Sure. My name's Nicholas Asher. I'm a researcher in the Koala project, and in particular, I work on explainability. Our task in Koala is to provide automatic explanations for both analytics engines and also cognitive advisor in Koala. I hope that we'll be able to talk about that at some point in these workshops. But here, I just wanted to ask a little bit more about the XAI side, Christian, of your talk, which was very clear and nice. Just two things. One of the things that we're very worried about here is when we're working with machines that can have serious consequences. So we aim to explain behavior of machines on the shop floor for workers on the shop floor. And so, and we also want to give them advice. So one of the kinds of machines we work with is a machine that makes industrial detergents, and they might mix together different detergents, different chemicals to make the thing. And so we want to make sure that the explanations we give are absolutely correct, because a bad explanation might lead a worker to actually create something dangerous, right? It could even result in an explosion or something. So for us, we are very worried about this correctness criterion. And for us, we think we have to go through logic. So what we have to do is translate the machine learning algorithm into logic, use the data as clauses, and then prove the predictions to be absolutely sure we're getting the correct explanation, because we have too much experience with agnostic, model agnostic explanations where we test and we see that the same clauses give an explanation in one case for one decision, but also are operative in the opposite direction. So, and there's a kind of counterfactual reasoning going on there that's not taken into account in the machinery of things like Lime and SHAP. And so, yeah, so we are very worried about this, correctness constraint. We were wondering, how do you see that?
Okay. Yes. So thank you for this question and also the explanation before. I don't think we will use this or we need this formal correctness of the explanation. I don't know it yet totally, but I guess we can work with data-driven explanations and the typical explanation frameworks, SHAP, Lime, and so on, in order to get some useful explanations that can be used ideally on the shop floor, or at least in the decision support system. I think what we plan is to have some kind of visually or textual recommendation that tells the worker what is going on, that tells him, for instance, which attributes of the machine or which sensors actually are producing this prediction. And I think it is very, very interesting to have this formal correctness, so to transfer this or to work on this challenge, basically to formalize this explanation in a very mathematical sense, in a logical sense, but I don't think we need this here.
Okay, thank you.
Any other questions?
Yes, we have some more questions, right?
They're in the chat, Christian. If you look at the chat.
Oh, the chat. Yeah, I have a small monitor here. Sorry.
So we have three questions on the chat. Let's start in, in historic order, right?
Yeah. Okay. Let us start with the first one. For explicability, how to decide which AI framework to be used. This is a good question. Because we already we just started with a survey of state of the art in explainability AI or XAI, and we know there are these fundamental methods, SHAP, Lime, ELIS, and so on, and that there are these frameworks that we could use based on this, BLimey or IBEX and so on. We are not decided yet which framework to use, but I think in the future we will have an answer to this question. The next question is human-centric dashboards. Can you elaborate a little bit more on these? We will like these will be like and who they are aimed at, what users. Yes, human-centric dashboards are basically some dashboards, in my opinion, that show the production process, that are easily to understand, that some kind of visual, and that somehow visually indicate the explanation or actually where something critical is happening. And I think this will be, just a monitoring at the moment. I don't know whether we go more into human-robot interaction. I don't know yet if this is a plan. We will see in the future if this will also be used in the dashboards. Then the next question, if you had to summarize the value of XAI manufacturing in a single statement, would you agree on saying that XAI is a way to transform risks into opportunities? Well, good question. But I mean, you always have the two-coin side of challenges and problems. And I think if you use sorry, you can, sorry. I think, yes, it's a good idea to transform the risk into opportunities, because if you know where the risk is, or what the risk is, or what exactly is the reason behind this risk, if you can go that far with your explanation, then you have the opportunity to improve that. Okay, with this, I am finished. Okay. Thank you very much.
Just to say to Nicholas, unfortunately, it's not part of my presentation, but in STAR, we have a scenario which is, active learning, human-robot collaboration, where we actually use counterfactuals, right? So that to help the robot understand what could have been done better, right?
Mm-hmm.
If things were different. Unfortunately, I don't have so much about this in my presentation, but I will be happy, to share some publications offline from the STAR project. So thank you, Christian. That was, I have also a final question, right? Since we have time. I saw that you mentioned that, a very important thing, right? That you want to empower the domain expert, through the dashboards. So people that they're not, deeply in the artificial intelligence, right? But still work in a factory. And we're going to see a lot of things like this, right? In the new workplace and in the new workforce. So I'm only wondering, you didn't speak so much about the fairness of the algorithm, right? So maybe everything looks okay, everything. The data are fair, but fair. I mean findable, open, accessible, and so on. But then your data are having some biases, and also sometimes unintended, which for me is very difficult for somebody who is not a statistician, right? To spot the problem, right? So because everything would seem, to work right, but then the unintended bias will create issues in the production process. So I don't know if you want to make a comment like this and why this is not part of your, framework that covers more or less a lot of things, right?
Yeah, I think fairness and in particular bias of the data, as you mentioned, is an important thing. I have not put this on the slides, but actually this is something we have to also address. Yes, of course. So we will address this also in the project, I guess.
Okay, so then we can move to our next speaker, Fenareti Lambathaki from Explainable Ai project. Fenareti, the floor is yours, right?
Thank you, John. Hello, everyone. I am going to share my screen right now. And I hope you can see it without any problem. Hello, I am Fenareti Lambathaki from Suite 5. I'm the technical coordinator of the Explainable Ai project. And in the next minutes, we are going to see a short introduction on Explainable AI, some key questions that are always associated with Explainable AI, what is the scope of our project, and then we will move on with some more insights about the Explainable Ai approach, about the concept, about who are our target stakeholders, and what is the progress we have made so far in our project. And obviously then some concluding remarks and certain, let's say, parts of our future work. Starting initially with a short introduction to the project, Explainable Ai stands for Explainable Manufacturing Artificial Intelligence. Our project started 11 months ago, more or less. It is a project coordinating by TXT in Italy, and it is in the family of ICT 38 projects. It brings together 15 partners from 7 countries and 4 demonstrators that are going to pilot and check the added value of our approach, the platform and the different applications we are building on in order to explain for specific problems we have identified what solutions need to be provided. But without any further ado, I would like to provide some additional remarks in respect to what we have heard so far about Explainable AI, trustworthiness, explainability, etc. Why it is so important. The first reason is that Explainable AI is firmly associated with human trust. How we can increase human trust in AI is something that really depends on whether the end users, the different stakeholders that are the audience of a specific Explainable AI solution know why the system made a specific prediction, a specific decision, why the system did not decide something else, what should change on the system on certain parameters in order to make another prediction, when and certain time parameters, when the AI system succeeded, what was the impact of a failed prediction as well, and what happens if I don't follow the instruction that has been provided by an AI model. And it is something that is critical, because if a human, the intended audience of a model, an AI model, does not understand how a certain decision has been reached, they will not easily adopt it. So we can mention and we can say that adoption of AI, even though there is a lot of buzz around AI, a lot of initiatives, a lot of work that is associated with AI, unless we achieve explainability, trustworthiness of AI, let's say the future, how the whole initiative goes, it is something that will not meet all the expectations that it is now associated with. Explainable AI is also associated with transparency, reliability, how we can, by explaining a model, by looking into its inner workings, by understanding the outcomes, we are in a better position, not able actually, but in a better position to understand whether there is any bias on the model, whether there are any unintended mistakes or miscomprehensions that have been inserted into a specific model. Or very often, when we try to ensure transparency, when we try to ensure fairness of the decisions, the model becomes too transparent, and there are certain fears around security, around privacy of a specific model. In addition, there are often many discussions about how we can ensure that an AI model is robust, is accurate, is performing well, without creating any additional liabilities. And the last question is really associated with what is often mentioned, that explainable AI is something that is happening under the hoods, involving different data scientists to understand the models, but it's not them actually. As mentioned earlier, it's about business users, it's about end users that really need actionable insights about a model, not just one prediction, but what it really means and what are the steps they need to take in order to implement such a decision that was provided. So all those factors, let's say, and all those questions are very much related with the number of challenges we have identified, and we feel that they are within the scope of our project. I'm going to start with, let's say, what we call traceable explainable AI pipeline lifecycle management. When we try to create an explainable AI model, it's not just about a model. It is a whole pipeline that needs to be created, different models that need to be trained. We need to experiment with different models to identify what is the optimal one. We need to insert in the pipeline explainability techniques. We need to validate the outcomes. We need to check and retrain at frequent intervals all the models within a pipeline we have included. And it is a pipeline that is something that is not, it is created by a data scientist, but it brings additional stakeholders, data engineers, on how this pipeline can scale, business user to help on the explanations on validating the outcomes. So it's not something that we can consider that is a one-off process that is undertaken once. The explanations that are associated with different models need to be managed, and they need to be managed at different phases, different levels. We are not talking about the model explanations only. We are talking about the inputs of the models. We're talking about the outputs of the models, different levels in which explainable AI techniques can be applied. How we package and we deploy the models and the pipelines we have defined in different execution environments in a way that, let's say, moves towards MLOps, AI ops in the direction in which DevOps had been moving over the past years. But also when we're talking about collaboration, we need to keep track of all the experiments we have performed. We need to be able to reproduce the specific results that we have created. In order to do so, obviously, we need data. And sorry, for some reason, animation doesn't seem to work. It is about data, efficiently, securely managing the data. It's about ensuring that we can integrate data from different sources, data that are fair, data that we can understand, we can properly manipulate, because the way we receive them, it's never enough. We need to scale the data, we need to apply one-hot encoding, different functions to ensure that the data will be appropriate to be used as input. But we also have a number of additional challenges that we need to tackle. Challenges related to what John mentioned earlier about inconsistent, incomplete, missing data, data that are not enough for training a model, or data, small data that may lead us to overfitting or underfitting models, or models that cannot be, for which adequate explanations cannot be provided. This is something that we are typically facing at the design, let's say, time, when we try to experiment with different models, with different explainability techniques. We're trying to create different pipelines. But even when the pipeline we have created and the models we have created are into production, still we must always monitor the different models, the different pipelines, and ensure that we effectively manage data drift, unexpected situations with which that our model had not encountered previously. And an additional aspect that we must have in mind when we are talking about a domain like manufacturing, in which the data are safeguarded, data are in many cases need to be kept on-premise, on private cloud installations, or locally within a factory. We need to have in mind data security, that data we may not always have at our hand the whole data set to play around. And this brings us to another challenge, a challenge that is related to sharing, a challenge that is related to collaboration between different stakeholders that need to consistently work together in order to create, train, evaluate, explain different models that need to exchange different assets. And when we talk about assets, as you will see in a few minutes, we're not talking about only data sets. We're talking about models, we're talking about features, experiments that we need to be able to securely share and exchange. And what we must not forget is also the aspect about the transparency paradox that I briefly mentioned earlier. While we try to increase transparency, we try to comply with ethics, we need to be able to assess the vulnerability of a model, we need to be able to check how, if it is susceptible to any data poisoning attacks, to any adversarial attacks, in order to ensure that everything we build, we try to make it explainable, but in a secure way as well, without compromising any aspect of the model. And this is a whole big discussion how this can happen. From our perspective in Explainable Ai, we are looking into different models, machine learning, deep learning models, and we have identified different what we call explainable AI circles. In any model, the first starting point to, let's say, move towards explainability starts with the data, understanding the input data, the structure, the semantics behind the data, having a grasp of the data through different samples, visualizing the data, performing exploratory analysis in order to know what exactly are the data, what they mean as they are provided by a business user. The second level is associated with what we call hybrid models. Typically, the different models are not explainable by design, with the exception of certain models that can be applied. In many cases, different additional models need to be created, surrogate models, feature relevance techniques, or even cases in which the data scientist can elicit explanations by example, for example, in order to ensure that an AI model can take a step further towards explainability. And the last step in which we consider that explainability should be taken in a more easy way, let's say, as granted, is when we are talking about directly interpretable models, decision trees, models that are, let's say, by themselves interpretable. When we talk about graph machine learning techniques that can also contribute to this direction, they are another, let's say, facet of explainability that can all contribute on making different models more explainable. The explanations that can be provided range. Obviously, they can be text explanations that are provided in different dashboards in different ways to the different stakeholders, visual explanations, trying to provide in different diagrams explanations that can be consumed by the target audience. It can be explanations that refer to explanations by example based on specific data from the training data set. And these are only some examples of explanations that can be provided. From our side on Ai, we are trying to create a catalog of explainable models that are associated with specific techniques, and they are available through the platform. Such models are directly interpretable, or post hoc explanations are provided on top of them. We are talking about models, either model agnostic or model specific techniques, obviously, techniques that are providing local explanations on specific results or global for the whole model. And we are cultivating, let's say, the approach of not considering the explanations and the creation of explainable AI model as something static, but as something interactive that brings together different stakeholders. Stakeholders like, obviously, data scientists, different data engineers, and business experts that all consistently work together in order to share in a secure, in a trusted way, data, different models that have been created, either as they are offered in an out-of-the-box manner by different libraries both for, let's say, the typical AI part, but also for explainability techniques, SAP, Lime, Alibi, Camel, etc., just to give some examples that we are considering. Sharing different features. Feature stores are on the rise right now, and they provide different functionalities that can help towards explainability. Experiment tracking, experiment sharing, explanation sharing, and trying to figure out what is the appropriate level to which the different explanations should reach. In order to understand the interactions between the different stakeholders, we have done certain brainstorming exercises within our consortium, trying to understand where explainability lies for different stakeholders, trying to understand the breakdown on different steps, how explainability can be achieved, what are the expectations, what are the challenges we expect to encounter. And from the business expert perspective, the let's say a number of steps are associated with how we get prepared for explainable AI, how we can provide, integrate, understand effectively the data we're dealing with. Each of those phases is presented right now per stakeholder, but obviously it requires interaction with the rest of the stakeholders that I mentioned. We're talking about how the different business experts themselves can contribute and can work together with the data scientists in order to help them make better sense and adapt the explanations, the configuration of the models, the evaluation of the models, in order to ensure that explainable AI models are created according to their needs and they are fit for purpose. And the last part concerns the consumption, in a way, of the insights they can get out of an AI model, an explainable AI model that is in production, how they can understand the results depending on the problem at hand, depending on what exactly is the context for an explanation, and provide those insights and the results in a way and in appropriate dashboards that are relevant according to their needs. When it comes to the data scientist, the steps are obviously more extensive. When it comes to how they can understand the data, the problem at hand, how they can prepare the data and handle problematic data cases, cases in which the data are missing, the data are not appropriate at the right granularity level, etc. How they can collaboratively design pipelines, not a single data scientist, but with collaboration between different data scientists, how they can include and provide additional techniques, how they can define what are the appropriate techniques, explainability techniques to use depending on the model they had selected in the first place, and how they can decide what is the most appropriate technique to explain the results according to the level of explanations that are expected by for each problem. And the evaluation of models, results, explanations is always obviously under the radar of the activities of a data scientist. This was one part of the activities we have been performing over the past months on the project. Based on the business requirements and the business cases that I'm going to talk in a few minutes, we identified a number of business requirements that essentially summarize what are the expectations of our business users, of our manufacturers, from the solution and the platform we are providing. Those business requirements were translated into a number of technical requirements, a rather extensive number of requirements that we grouped together into different features that led us into what we call our minimum viable product. The minimum viable product is essentially what is the expected outcome of our project in terms of functionalities that are going to be offered by the Ai platform by the end of the project, in order to ensure that both our demonstrator perspective and the technical partner perspectives are reconciled. We have asked for voting by the different partners in order to identify from the demonstrator perspective what is the added value per feature that they identify, what is the added value they identify in the whole industry, but also from the technical partners to assess the innovation of each feature based on the state of the art and from a more scientific and technical perspective, the complexity and the feasibility of each feature within the project. What is worthwhile mentioning, because obviously we don't have the time to dive into the details of what the MVP is all about, is that the features that were ranked the highest were the explainability features, features that are related with with how we handle and manage explainable AI models and how they are included in different pipelines, how the different stakeholders collaborate. And those are obviously broken down on different requirements that have been defined. And those are the features that were ranked as the most complex one as well, which was also kind of expected by our technical partners. When we look at what we are going to provide, we are going to provide a platform and different applications. I'm highlighting this distinction because the platform is intended to be utilized by the different stakeholders we have in our project, the different roles that I mentioned at high level, data scientists, data engineers, business users, in order to prepare, configure, train, experiment with different models, with different pipelines. Obviously, this interface and the platform is not the interface in which the explanations, the predictions, the guidance to the different demonstrators is going to be provided. We have different applications that are developed. Some of them are mobile applications, dashboards, AR application as well, in order to ensure that the different, depending on the demonstrator, depending on the case we are handling, we are providing to them the results of AI, the results of the explanations in a way that is digestible to them. I'm not going to dive into, let's say, the breakdown of the architecture. There are different services that are associated with data, with models, with pipelines on how they are created in order to handle effectively all the life cycle of everything we're dealing with, and ensuring that everything we are providing, the different models, the different pipelines, can be executed both on a centralized cloud, but also if there are certain security restrictions on the manufacturer side, we can provide part of the functionality of the platform to be installed on a private cloud on premise by a demonstrator. Our 4 demonstrators are related to production optimization, product demand planning, product quality optimization, and semi-autonomous measurement planning. We can see different problems that have been identified by our demonstrators, and we are right now trying to work on what exactly are the different models and the different algorithm families that we need to include in our catalog in order to ensure that those problems can be solved, both from, let's say, the traditional perspective, but also the explainability techniques we need to include. And where we are right now in terms of achievement, just as a summary, we have concluded the state-of-the-art analysis, identifying what is out there, what are the algorithms that are more related to explainability, the different techniques, the different libraries, the different approaches in manufacturing that are in place for explainability. We have defined in detail the business cases, we have defined the business requirements, we have extracted the technical requirements and the MVP. We are at the position right now of designing in detail the different architecture, for the platform and the applications, but also the different methods for the different asset management techniques and the AI bundles that embrace all the different functionalities I mentioned. So to conclude, data is obviously important in order to ensure that we can have the analysis we need, but we need explainability to ensure trust and adoption. It is not a one-way path, and this is why we are working intensively on how we can cultivate collaboration between the different stakeholders. We know that explainability-focused platforms, not libraries, not techniques, are still in their early steps. And from our side, the next steps in our work is to finalize the design of the platform and the applications, to conclude on at least the initial, let's say, list of models that are going to be included on the Explainable Ai catalog, develop the platform and the applications, and we have in 1 year from now approximately the first release, and to validate the results in our 4 manufacturing cases. Thank you for your attention. Sorry for taking a couple of minutes more. I'm at your disposal for questions. So
there are some questions on the chat, right? So
okay.
You want me to read them or you to?
I am just
Very
taking them. So how we have connected the outcomes from the Miro collaboration boards and the identification of the MVP. Okay, there were many steps that I have not presented that are intervening between the boards that I presented that were collaboratively created by the different partners. Apart from, let's say, the different steps and the breakdown that was done in terms of the user journeys, we also had at our disposal the business requirements that were more, let's say, focused on our business cases. And based on those 2 inputs, we had practically 3 boards, one for business users in general without identifying specific roles, one for data scientists and another one for data engineers that I did not include in my presentation. And we extracted a list of technical requirements that were around 140 technical requirements. Those technical requirements as a next step were categorized, they were grouped together in order to extract certain features, certain functionalities. It resulted into around 48 features that were candidate for our MVP. Those were voted, and in the last part, once the voting was something that took us approximately a couple of weeks, let's say, to go back and forth in order to ensure that we are all on the same page on the different requirements, what each of the features implies, and how the voting needs to proceed from the demonstrator perspective and from the technical perspective. And the consolidation of the MVP practically means that we have must-have features on our platform, like the ones I mentioned for explainability. We have should-have features and some optional, let's say totally optional features. The sum of the must-have and should-have are around 28, if I remember correctly. And the voting was something that happened offline through, not on Miro, on Google spreadsheet. Then for the next question about the workers in the chart of stakeholder, we are looking at all end users. Either we are talking about workers, managers, end users, let's say, in general, in the scope of business users. And this is, if one looks at the board we had in Miro in detail, there are things that highlight that there is a distinction, obviously, between those roles and what they expect, but we could not dive into all the different workers versus managers versus all the different roles we should have included. And this is why we had decided to stay at a higher level, at the business user level. So the process, the whole process from the user journeys till the MVP, it took us approximately 4 months to go step by step. yes, more or less 4 months. It was not one day, 1 week. It is something that concluding all the steps, it's something that takes time because of it's not from all the intermediate steps that I mentioned as well. I'm not sure if I have missed any other question on this on the chat.
Yes, Fenareti, I guess there is a hand up by Felicien. I don't know if I pronounce it correctly.
Yes, of course. Here, Felicien, the technical project manager of Assistant. So thank you for this great presentation. A lot of important concepts were discussed here, especially how to bring Explainable Ai to the show floor. However, it happened that the language of system builders is not the language of workers. So the question is, did you think about what could be the degree or the granularity of explainability of AI in order to boost the decision time of workers?
This is something that we are actually currently working on. I don't have an answer right now because we are working both on the selection of the different models, the different techniques, but also on the level of explanations that the target users will require. So hopefully in the next meeting we will have in some months from now, I will have a more concrete answer than what I can say right now.
Thank you so much.
Thank you.
So I think there are no more questions, right, Fenareti? So
yes, I think so. Thank you.
Thank you for the presentation. So maybe it's my turn, right? So I need to just to share my presentation. I hope you can see it right now, or it's coming.
Yes, we can see.
Okay. So I don't know if I introduced myself previously. So I'm John Soldatos, Intrasoft International, STAR project. I'm the technical coordinator of the STAR project. So I think I'll contribute some complementary perspectives to other projects about how we are using, of course, some overlaps as well, how we are using explainable artificial intelligence in the STAR project. Just a quick look who we are. We are a consortium, 15 partners coordinated by Intrasoft. You can see major industries here, but also SMEs and academic partners. And what we try to do in this project is to help manufacturers and industrial solution integrators develop and deploy trusted AI systems in manufacturing lines, especially in non-trivial scenarios. So we're not a project. We are a project on AI and trust. Which means that XAI is a powerful tool for us. However, XAI is not our primary line of research. So here are the things that we are looking at when it comes to AI and trust or trustworthy AI systems. So we are looking at cybersecurity for AI. We are looking at putting the human in the loop and fostering human machine and human robot collaboration, and also an interplay for exchanging knowledge between humans and machines. We are also looking at some technology which is called simulated reality, and it aims at accelerating the convergence of a reinforcement learning system. And of course, we use explainable AI as tool. So our approach, our concept for AI is that we acknowledge the importance of going to a black box model that you can hardly understand, which raises different questions. Why did you do this? Is this really the best thing we can do? Is this really efficient? And can this, what you recommend, be trusted? To some explainable model that can reinforce the trust of the manufacturing stakeholder, the worker, but also other stakeholders on understanding why AI recommends or is doing something, why this is one of the best options, and why this can be trusted. Now, again, for us, XAI is a tool, and we use it for different things in the project. First and foremost, as already mentioned, was to explain decisions of AI-based systems to different stakeholders in the manufacturing setting. Also to use the explanation in order to optimize the way you perform a task, and also to regulate the degree of autonomy. So what can be done fully autonomously, what should be done with a human in the loop, and so on. Now, for this thing, which is called simulated reality, and which of course requires a lot of data to run upon, we use synthetic data, we use synthetic data generation. And then XAI comes as a add-on to make sure that the data we're using are relevant and trustworthy. We're also using XAI for security, like identifying adversarial actions and cybersecurity attacks. And overall, we have also a legal and ethical compliance task. This is carried out by lawyers, by legal experts, not by technical people in the project. And as I asked Eduardo earlier, XAI and transparency in the models you use is one of the mitigation measures. So I'm going to go talking a little bit more about each one of these uses of AI. Just to position, we have this high-level reference model of STARS functionality. So we are doing things in the cybersecurity domain, so like protecting AI systems from adversarial attacks like poisoning or evasion. We are doing things in the human-robot collaboration domain, like active learning, like provision of feedback into the human in the loop processes. And we are also having operations in a safety domain. We are trying to ensure the safety of different AI systems, and there XAI is also a tool. As you see, we have XAI at the bottom of this reference model, because it is used as a tool by more or less all of these use cases in all of these domains I mentioned previously. Well, we have this also more detailed architecture. I'm not going to go through it. However, it's interesting to see that our process is, on the one hand, to secure the data, and we do this by applying data provenance on the data, so we keep track of statistical distributions, other metadata of the data, and we very much care about any adversarial attempt to change the data, to tamper with the data, and change some statistical properties. So all our data passes through a cybersecurity, cyber defense layer that makes sure that our data are trusted at the first place. This has been already discussed in one of the previous talks. And then all our AI algorithms, including the XAI, are presumably working on trusted data. And then we use it to do different types of AI systems including machine learning, deep learning, reinforcement learning, but also active learning and more. So to this end, we are developing a library of XAI techniques. Again, this is not so prominent part of our project. For example, comparing to Human-Centric Ai presented earlier, where I understand that this is one of the most core objectives. So in principle, we have different techniques in this XAI library. These are algorithms to be explained, usually algorithms that are not white glass, but they are black box algorithms, specific instances with predicted classes without, of course, understanding the process. And our output is different kinds of explanations and also their visualization. What is important here is to switch and probably select some model that can be explained, some white glass model, without compromising performance. So this is one of the objectives. Now, we are using we have deep learning, for example, for quality inspection in our project. And to this end, we use different explainability algorithms that work for deep neural networks, like LRP, and some variations of it, like prediction difference analysis, like LIME, as it was mentioned a couple of times before, and as we know, it's a model agnostic technique for XAI. Then we've got also techniques that visualize the outcomes. And part of the work is to feed a deep learning model to one which is more relaxed. It is simpler and can be explained. It is a human interpretable. Now, let's go into some So first use case is explaining decisions. Now the scenario here is a quality inspection, right? So you see a part, the algorithm is classifying based on deep learning whether this part is okay, is not okay, and then through the explainability of the classification model, so image data and attribution methods, you want to produce attribution maps and then visualize in a kind of heat map, and then highlight the features that matter the most for taking a decision. So we try to answer why the AI classified this piece as defective. Of course, a part of our research involves evaluation of the quality of the actual explanation, considering time complexity and, of course, the semantics to the humans. So how easy it is for the humans to understand these explanations. Now, the second use case is we explain human-robot interactions and also the movement or the placement of movement of mobile robots, autonomous mobile robots in the shop floor. We do this in a pilot plant, in a DFKI and Smart Factory. The previous quality inspection scenario was in Philips plant. And there we are doing post hoc explainability, right? So we are taking the outcomes of the reinforcement learning techniques, which we use to ensure the safety, to learn, basically to help the robot learn based on a reward, how it should move in the plant in a safety way, so across safety zones. And there we want once the deep reinforcement learning converges, we were using explainability for post hoc purposes. So to make sure that the training and the operation of the robot is in the right direction. Now, going to the simulated reality system, the term, well, is used, but yeah, it's not a buzzword or a blockbuster term yet. So what is the idea of simulated reality? The idea is that because we know the benefits of reinforcement learning, and of course we know the limitations of reinforcement learning, and in a plant the problem is that you cannot do this trial and error, and of course that it takes a lot of time to converge, even if you have the luxury to do trial and error in the plant. The idea here is to create a simulated reality, so a simulated setting where you can run the reinforcement, which of course represents faithfully the reality, and then use there to run the reinforcement learning and achieve faster convergence. Now, what is the problem there? The problem is a lack of data. So you need to do some data augmentation. So you need to produce sufficient training data. Yes, you can use different techniques from computer vision to generative adversarial networks, variational autoencoders in deep learning, and also in reinforcement learning, for example, through keeping track of robot trajectory logs. Now, how to produce more training data? We use a simulator, in this case, a robotic simulator that generates synthetic data, and then we need to transfer this to the real world. Now, you have to make sure that this data makes sense, right? They are realistic and they are right. And this is where the XAI comes in as part of the process which we call confidence assessment. So upon the generation of the data, they are explained to the worker what this data are about. So this is another use case for explainable artificial intelligence, not mentioned so far, which, however, increases the confidence in the reinforcement learning system. This was mentioned before by Fenaretti. This is, of course, one of the ways we use XAI, and it is to detect and to mitigate cybersecurity attacks. We know that AI systems can be susceptible to different types of attacks, like, for example, poisoning attacks at training time. And this can be a possibility, especially if you leverage the newest data. So you train or you retrain frequently the algorithm. So if a malicious party injects poison data, then it compromises the ability of the deep neural network or other AI system to take correct decisions, like do right classifications. Likewise, evasion attacks, you can give an input to this works in runtime, by the way. You can give an input to the deep neural network, which is very close, very similar to inputs that the AI is able to classify correctly, but it fails completely to do this. It is quite common in deep neural networks. Again, we want to mitigate this, and we want to remedy this by training the AI system to identify such evasion, such adversarial input, and we can, work exhaustively by using formal methods and training exhaustively with different types of inputs, including the adversarial input. But to do this, first you need to identify that you've got a problem, and there we use XAI and features ranking of XAI to gain insights on whether the deep neural network is working well. So we create adversarial attacks we simulate adversarial attacks, and then we can detect them based on different techniques like statistical analysis of spatial entropy, but we can also use sub-signatures and features ranking, so as in principle to detect a possible change on the sub-signatures after the training, right? Which, you know, a smart hacker will usually do this without tampering the statistical distribution. So the statistical distribution might look okay, but the sub-signatures could betray the attacker. So this is how it works. Of course, as we said, all our data passes through our cybersecurity layer. So our data are trusted at the first place. The XAI is for detecting higher level attacks like poisoning in this case. Yeah, that's a slide that I added just during the course of this seminar. This is where we use the counterfactuals that were discussed before in one of the previous talks. It's an active learning scenario. So basically, in an active learning scenario, it's a human-robot collaboration scenario. So the idea is that the AI system, the robotic cell, for example, can consult an authority like a human in this case about cases where it lacks adequate knowledge. And then the human can provide insight and in this way accelerate the knowledge by the robot. So this is our active learning scenario, and we are working on implementing also a natural language interaction. So like, you know, the robot can address a question to the human can give an answer, and then the robot to know to acquire the new knowledge and update the knowledge base, and in this way, as I said, accelerate knowledge acquisition. Now, the XAI module is used there in the knowledge graph, again, to augment the knowledge, and counterfactual explanations are also used so that we provide the robot with information on some alternative quality inspection sequence that would have worked, right? Yeah, sorry for that was not planned, right? I just put it there, and I think my colleagues in the STAR project have already a couple of papers with this, and I will be happy to share them. So that's all about STAR and how we use explainable artificial intelligence. I think for this presentation, but for all presentations, we are going to make them available through the clusters webpage, but also in our case through the STAR webpage, along with all the presentations. And of course, the recording, if you want to revisit this seminar and the question, what has been said. So I'm happy to take any question.
I have one, John, or actually two. They're sort of related. So thank you very much for the talk. Doing a lot of stuff, and there are many connections with Koala's work too. But I wanted to ask, you know, one thing that you brought out, I think, is when we think about, I think time complexity is very important, because sometimes we want to offer explanations in real time. And so we need to have results. But for us, we only have these provability results for complexity results for relatively simple architectures. So I'm wondering your thoughts about, and this is really a question I wanted to ask the previous speaker too, should we ask stakeholders to consider maybe less complicated architectures that will be in principle more understandable, yes, even if there's a small loss of accuracy?
Even I said, Nicholas, in one of the slides, right, that it makes sense to put down the requirements of your scenario and resolve trade-offs. So, yeah, you know, if you have just a very small improvement from in model accuracy, thanks to deep learning, then maybe I think for me it's it's not a good idea, to use a deep neural network, and then, which it's always difficult to explain, and all the explanations also can be debated. If you can achieve the same result with a decision tree or a random forest, something that you can, explain more easily.
Yeah.
Also in this direction, because, this area is the research in this area is accelerating like crazy. So the most recent papers I've read, they try also to quantify the explainability, right, in some sense, so that you can use it in a trade-off analysis, okay? So you need some score for the performance, and you need some score for the explainability. So I've seen, recent papers, 2020, 2021, where people try to quantify the explanations. So they put down different factors on the quality of explanations, like, I don't know, how intuitive they are to humans. This is another concern, how well they are visualized, then how fast the explanations can execute. So a number of parameters, right? And they try to create a score so that you can take this into account in trade-offs, right? And you can, on the one hand, you can have the accuracy, on the other, different levels of explainability, right? Class A, Class B, Class C. I think Fenaretti was showing something similar. I don't know if it is quantitative. So I think I saw a couple of papers with this line of research into 2021. And of course, there are in the community some people that they say, don't use, black boxes. If you care about explainability, avoid them at the first place. Don't go there, okay? Now we know that deep learning is what is trending, right? Because it apparently gives better performance, especially if you have more data. So that's the reason we have this interest on deep learning. However, there are all authors and there are papers which say, if you care about explainability, don't go there as a first option.
Okay, yeah, thank you very much. Yeah, there was another remark about decision trees, but we can take that offline if you wish. It's just that they contain redundancies, and so you may want to get a minimal.
Yeah. The decision trees have some problems in knowledge representation, right? But in general, a decision tree I can decompose to a if-then-else rule set, right? In principle, which is something that the human can understand, right?
Right. Yep. Okay. Thank you. Thank you so much.
So that's it. I don't know. I think we are, unless there are any other questions, I think we can close the meeting. Paolo, make sure that the recording becomes available in the cluster site, and we can collect also the presentations. And thanks for everybody for
John. Sorry, give me just 1 minute for a couple of words on the AI for manufacturing.com website, if you will. Just for all the community, AI for manufacturing.com is a newly born website. Is a virtual place, a sort of community where to find and share info, articles, publication, news, use cases about both AI and manufacturing. It was created based on input from the ICT38 cluster of projects. And in order to provide an opportunity, an additional opportunity to those who are interested or learning or working or researching about AI and manufacturing. We had an opportunity to create this community within Koala. That is one of the projects that Nicholas also mentioned before, earlier on. And basically, the site is up and running since 3 weeks, is a baby, let me say. The initiative is open to all projects, not only ICT38. And I warmly invite individuals and groups that want to share or contribute materials, publication, or thoughts about AI and manufacturing. So I'm putting here in the chat the site.
The site, yes, excellent.
And so that's it for me.
Thank you, Paolo, and thanks everybody for joining, and thanks for the speakers, especially Fenaretti, Eduardo, Christian. That was great, and see you in one of the next workshops, right? That was only the first one out of a series, so you can expect many more workshops in related topics like human-robot collaboration, training and skills in the workplace, and other relevant topics. So thank you very much.
Thank you.
Thank you.
Thank you. Bye-bye.
Thank you. Bye.
Bye.
Thank
you. Bye.
Bye.